9i, derivatives of circular functions. There are three circular functions that we know of, sine, cos, and tan, and today we're going to learn about their derivatives. Each of these derivatives do have proofs. They're in the textbook, but they are quite large, so I'm not going to go through them today. But I definitely do encourage you to go to your textbook and to have a quick look over how we get these derivatives in the first place. First rule that you need to know, the derivative of sine will be cos. So sine becomes cos. If we have a function on the inside, whether it's something simple like kx or whether we have an actual function, just like we had with our exponentials and with our logs, we'll apply the derivative of that inside function, which in this case would be k, by the derivative of the outside function, which is sine k of x, so that becomes cos k of x. And yes, this is the chain rule, so it's the derivative of the inside multiplied by the derivative of the outside. So in general, if we have f of x is equal to sine of gx, then our derivative will be the derivative of the inside, which is g dash of x, multiplied by the derivative of the outside, which is cos of g of x, remembering that you don't touch that inside bracket. Rule number 2, cos becomes negative sine x. So you just need to remember that sine becomes cos, but cos becomes the negative of it. But the exact same thing applies for the inside. Whatever the derivative is of the inside, you multiply it by the outside. So if I have k of x, then it becomes k comes out to the outside because that's the derivative, and the derivative of cos is negative sine of kx. Same thing if we've got any kind of function on the inside, we pull it out, that will be g dash of x, which is the derivative of the inside, multiplied by negative sine of gx, which is the derivative of the outside. Tan is a little bit more interesting because the derivative of it is a circular function you haven't heard before, which is sec squared x. Now, sec squared x is just simply 1 on cos squared x. So you just need to remember this rule, tan becomes sec squared x. Once again, if we've got a kx on the inside, you multiply the derivative of that inside by the derivative of the outside, and that applies for any function that you may have. It will be g dash of x, so the derivative of the outside multiplied by the derivative of the inside, which is the chain rule. Let's go ahead and practice this on a few examples. So for example 15a, differentiate each of the following expressions. So all you need to remember that the general rule is that it's g dash of x, so the derivative of the inside multiplied by the derivative of the outside, which as a composite function, g of x is sitting within the bracket. So for part A, we've got dy by dx, so that's the notation for the derivative there. The derivative of the inside, so the derivative of the inside here will be 2, and then multiply that by the derivative of the outside. So when I derive cos, it becomes negative sine, and the 2x, or the inside function, remains as it is. So that will equal negative 2 sine of 2x. Same thing for part B. So what we're going to do is, once again, the derivative of the inside. So if that's x squared minus 2x, the derivative of that is 2x minus 2. Make sure you put brackets because there's more than one term, and that will all be multiplied by the derivative of the outside. So the derivative of sine is cos, so that will be cos, and you don't touch the brackets, you leave it as it is. I won't need to expand that, otherwise I'll end up with 2 terms of cos, so it's a little bit nicer, like looking like this. For part C, all we now have is a coefficient out the front. So that coefficient just stays as it is, so you can pretty much just ignore it. So we're going to write 2 times, and then we're going to go ahead and derive it. So remember, it's the derivative of the inside, which in this case is 2, multiplied by the derivative of the outside. And the derivative of tan x, or tan of g of x, is equal to sec squared of g of x. And our g of x in this case is 2x minus 1. So now all we need to do is just simplify that, and we have our answer. Last example, here we can see we've got 2 terms, but that's fine. All you have to do is just treat each term on its own and derive them individually. So once again, we've got a 2, a coefficient, so we can just leave that. Derivative of the inside, so the derivative of 2x minus 1 is 2, and then times that by the derivative of the outside. So the derivative of sine is cos, and whatever is in the brackets remains. That will be, because there's a minus there, that will be minus, and now once again the derivative of the inside, so that's x on 2, which means the derivative is 1/2, multiplied by the derivative of the outside. Now the derivative of cos is negative sine, and this time it'll be x on 2. Let's just put this all together. 2 times 2 is 4, A negative and a negative makes a positive, and that will be a half sine x on 2. And that's pretty much it for the derivatives of circular functions.